Good morning, all. In the last class, we were discussing about the simple pendulum, and we have seen that then you have seen that this is what we have learned. It means the pendulum shows correct time. Understood? This is what the correct pendulum is. Understood this? Now the
Yes, sir.
problem comes is whenever there is a change in temperature, however, if temperature increases, say let's call this as theta 1, theta 2 degrees, which is greater than theta 1 degrees Celsius. What will happen?
Length of pendulum increases.
Length of pendulum increases. So, what will happen? Time for one oscillation
increases.
So, you can see that in 1 minute duration, it makes less number of oscillations. Agreed? So, due to that,
Shows less time than actual time.
we can say clock loses time. Agreed? Now we have seen loss of time per second is nothing but that has come to this is 1 by 2 alpha theta 2 minus theta 1. Remember this? Clear?
Yes, sir.
Suppose in 1 hour they ask. This is per second now. 1 hour consists of 60 minutes. Each minute has 60 seconds. Like that you can find out. Is it clear? This is what we have been discussing in the last class.
Yes, sir.
Shall I turn this?
1 minute, sir.
Completed.
1 minute, sir.
We have finished bimetallic strip now.
No, sir.
Did not. Write fast.
1 minute, sir. Done, sir.
Now, on the other hand, if temperature decreases,
Pendulum moves faster.
One oscillation
Length
increase
decreases.
and
Gain of time.
time, more time than the actual time.
what will happen?
Length of pendulum.
Length of pendulum decreases. When length of pendulum decreases, what will happen?
Time for one oscillation increase. Decreases.
For example, in 1 minute,
Thirty oscillation.
clock shows more time. So, what is the meaning of this? Clock
Runs faster. Gains time.
Okay, same thing. See, remember that here we have theta 1 minus theta 2. Remember, here theta 1 is greater than theta 2. Agreed?
Agreed, sir.
Shall I turn this?
1 minute, sir.
1 minute, sir. Sir, I have a doubt.
Till.
Sir, we are saying over here that to show correct time, right? So how did we find out what the correct ideal temperature is for measuring correct time?
Room temperature.
So, sir, how do we know
That is,
that
no,
that is
no, that is
correct
the
time?
reason why, wait. That is the reason why we'll never use normal pendulum. We'll use something called as inver. Inver has negligible expansion. We choose materials which have almost alpha is 0, so that the variation will not affect the time. Understood this?
Understood, sir.
Yes, sir, understood.
Suppose the clock is made of inver pendulum at a temperature, some temperature, room temperature. Even if season changes also, the temperature may change, but inverse still has almost a negligible expansion. That is the reason why you read chemistry, which materials will not have any variations. Shall I turn this?
Yes, sir, completed.
So one.
All last week you completed all this.
Okay, sir.
Shall I wait?
So
Hello?
no, sir.
Hello? Completed.
Yes, sir.
Now take some problems. Is connected to a small heavy ball. If it shows how fast so this is what he has again. You can see that 20 degrees. Temperature is increasing now.
Yes, sir. So it loses time.
It will losing time or not?
Yes, sir.
So
The clock will be slow.
you have to find out in a day. Understood this?
Understood, sir.
He's saying that in how fast or slow. So instead of measuring 86400 second, it will measure lesser than that. Shall I turn this?
Yes, sir. Completed.
Wait, sir.
Fast, fast. Completed?
Yes, sir.
A clock with a metallic understood this. Find alpha. See here,
Two equations, right, sir?
see first case 5 seconds faster. This is time lost or gain in a day now. Fast each day. That means the temperature is lesser, no? Let us
Yes, sir.
assume that
Yes.
clock show correct time at temperature theta degrees Celsius. Then 5 seconds fast. It gains, no? Therefore, in a day, gaining means temperature should be lesser, no?
Yes, sir. Degree.
Yes, sir.
it loses slow. That means temperature must increase now. That means it should be 30 minus theta. Understood this? Agreed or not? Just divide one by the other, you will get 30 minus theta by theta minus 50. You will get theta. Once you get theta in any one of the equations, you substitute, get alpha. This theta, either you put it here or here and get alpha. Understood what is being asked?
Yes, sir. Understood.
Any doubt?
No, sir.
Your turn there.
1 minute, sir.
Answer is 20, sir.
Theta is 20, sir.
Sir,
No,
20.
theta is 20.
Yes, sir. I got 20 only.
Substitute that, you'll get alpha. In any of these equations, substitute, you'll get alpha.
Yes, sir. 1 divided by 43,000.
Sir, got sir.
Yes, sir. Completed. Got the same answer.
Your turn there.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, once your previous page, sir, I will take screenshot.
Finished?
Taken, sir. Thank you.
See, you have something called as bimetallic strip. As the name indicates, it consists of two metal strips that are joined together. Now, you will be keeping clamps at the ends so that it cannot expand further. Okay, so this is alpha 1, this is alpha 2. This is at temperature theta degrees Celsius. When you heat it, See, this upper one tries to expand. Say, for example, alpha 1 is greater than alpha 2. When you put it in a higher temperature, when you try to increase the temperature, what will happen? Upper rod will be, this is rod 1, rod 2. Now, when temperature is increased,
Alpha 1 will increase.
rod 1 will have
Tendency to increase.
more thermal expansion. Do you agree with this?
Yes, sir. Yes.
Agreed, sir.
Than rod 2. See, this rod tries to expand more, but it cannot. So what will happen? Because they are fixed, this tries to pull this rod like this, no? Because the upper rod, the lower rod cannot move. Both are fixed only. So what will happen at the end? It will be taking a shape like this.
Sir, rod 1 and rod 2 are interconnected with each other.
I told no, they were clamped at the ends. They were clamped at the ends. This
Okay,
is
sir. Okay, sir. Got it.
clamps. Understood this?
Understood,
Now
sir.
you can see that this will take this strip. You can see that on which side.
Understood, sir.
It will bend on the side which has higher alpha.
Is it a temperature? Now on the other hand, if it is cool,
We'll take a convex shape. Concave shape.
there is the convex side now.
Sir, concave, right?
This is concave, this is convex now.
Yes, sir. Yes, sir. Sorry.
Okay, this is the temperature theta 3 less than theta 1. Understood, this is the functionalities of a bimetallic strip.
So that first one is for higher temperature and this is for lower temperature. No?
Here, I told here, no, theta 1 greater than theta 2.
Okay, sir.
The metal of lower alpha will be on convex side, sir.
Completed?
1 minute,
Sir,
sir.
that
1 minute.
is metal of lower alpha will be on convex side, sir.
Hmm. See, man, here higher alpha, convex, higher temperature. Lower temperature, lower alpha will be there now. Finish this.
1 minute, sir. Completed, sir.
Hello?
Yes, sir. Completed.
Wait. 1 second. Note on this, man. Visible? See,
Visible,
from
sir.
here, center of the lower strip to this center, this is R1. From here to here, R2. From here, the center of the second strip. And distance between these dotted lines is small d. And from the middle of this to this, it is capital R. Understood this?
Sir, for the first strip, that is LB.
Which one? No, no, you take this as L2. This is L1. He has
Okay, sir.
taken steel and brass. Write this as L2. This is
Okay, sir.
L1. This is R1, R2.
Got it, sir.
Shall I turn this?
1 minute, sir.
Or if you clear or not? Brass one you take second R2. Below one steel R1. Steel L1, brass L2. Shall I turn this?
1 minute, sir. Drawing, sir. 1 minute. Sir, the capital R is?
Mean radius from here to this dark one.
Sorry, sir.
Mean radius, average radius from here to here.
Okay, sir. Got it. Done, sir.
Completed?
Yes, sir.
Yes, sir.
Right. Now you have to find that mean radius only. That's what I'm saying. Radius of curvature of the strip, bimetallic strip we need. Okay. See, initially you are having a strip like this. This is alpha 1, this is alpha 2, this is L naught. Say temperature theta 1 degrees. Now you have seen that they expand. Due to unequal expansions, it will be bending. Okay. Now we are from here to here. This is the radius, mean radius. Agreed.
Which radius, sir?
Say,
Agreed, sir.
let this make an angle of some phi, the strip angle. Okay. And this will become L1. No? The length will change or not?
Yes, sir. It will change.
Any doubt is there? And he says that this small dotted part is R2 and the small dotted one, this is R1. Agreed?
Yes, sir.
Agreed, sir.
And this distance is taken as D. This is what we have marked over there. Agreed? So here at higher temperature, theta 2 greater than theta 1 degrees. The situation is this. Now you can see R2 minus R1 is nothing but D. Okay?
Yes, sir.
And average radius R followed this.
Yes, sir.
Now you can see that do you agree with this?
Yes, sir.
And also you have see arc by radius is how much, man? Angle, remember this?
Yes, sir.
Therefore, this is the arc length. So L1 by R1 is 5, or L1 equals R1 5. L2 by R2 is 5, or L2 equals R2 5. So far followed?
Yes, sir.
Yes, sir.
Understood, sir.
Clear? So now
Yes,
if
sir.
you add these two, agreed. So now what is L1? Substitute those values. Do you agree with this? If you take L0 common, R1 plus R2 is what actually? Any doubt is there?
No, sir.
No, sir.
Shall I turn this page?
1 minute, sir.
Note down in this order. Clear?
Yes, sir. Clear.
1 minute, sir.
Now, if you subtract these equations, okay, what is that you will get? R2 5 minus R1 5. Agreed? So this is it will get cancelled, no? You will get this. Do you agree with this?
Agreed, sir.
Yes, sir.
This is nothing but what you got, D only, no?
Yes, sir.
In the last part, divide these equations. If you divide these equations, L naught into 2 plus is 2R5, no? The other equation is L naught into D5. If you divide one by the other, what is the equation you will get? Do you agree till here?
Yes, sir.
So that means the last part we need R. By the radius of bimetallic strip. Any doubt is there in this?
No, sir.
Sir, we are taking D5 because of small change in radius, right?
Which one?
In the E part, sir. D5.
Hmm. Hmm.
Down, sir, down.
This
The
one.
last one. Yes, sir, because of the
No,
small change
already
in
it is
radius.
given here D.
Oh, sorry, sir. Sorry, sir. Never mind. Sorry, sir.
See, this is already given everything. There is no assumptions I made here.
Yes, sir. Yes, sir. Really very sorry. I did not see that.
Shall I turn this?
Yes, sir.
Wait, sir.
Shall I turn this?
Yes, sir.
Right. This is the radius of a bimetallic. So now what is the when a bimetallic strip is heated, what happens? It
It,
bends.
yes, sir.
Okay. And the mean average
Sir, 2 plus theta 1 plus, sorry, alpha 1 plus alpha 2 delta theta by 2 alpha 2 minus alpha 1 delta theta.
they agree with this.
Agreed, sir.
Clear? Now alpha 1 plus alpha 2 into delta t is very small. Remember, alphas will be in the powers of 10 power minus 7. So they can be neglected. Therefore, R is approximately 2 by, you can neglect now. Suppose you have 10,000 rupees. If you lose 50 rupees, you won't mind for that. Suppose you have only 100 rupees, you lost 50, definitely it will matter.
Yes,
So
sir.
comparison should be made between these two quantities which are being added or subtracted. Okay. So approximately this will be the radius of curvature. Is it clear?
Clear, sir.
Prabha, wait, just shut up your mouth and let's other complete.
Sir, someone has come into our classes.
Let them come. As long as they won't disturb, they can come. What is there in that? Today, madam is not there. Completed?
1 minute, sir. 1 minute.
1 minute, sir.
So,
Sir, wouldn't alpha 2 minus alpha 1 delta theta be also negligible? So can we take R as
no. That's what I'm saying. Whenever two things are added or subtracted, you can compare, no? Is only one term. With what it is negligible, you are saying? Negligible with what?
with the D, sir?
Huh? They're
Sir,
not
in the
being
last step, the last
addition
one.
and subtraction only should be taken account. Division
Okay,
cannot.
sir. Okay,
Hopeless
sir.
fellow. See, idiot. What happened to your minds, man? This is very small. You'll neglect. This is equal to what? 2000. You'll neglect that.
No, sir. No, sir. Sorry, sir. Sorry, sir.
The smaller this is, the value will be more.
Understood, sir. Understood. Sorry, sir.
Today is a National Science Day. C.V. Raman. His soul will be having tears, I think, seeing our present generation. What they have done for for the whole world, humanity, and what is that we are doing still. It's a dilemma. They should have enjoyed better because they used to have natural food. That time
Hey,
weather
just
is good.
shut up your mouth and do your own work. Don't interfere always and disturb others.
Who is this fellow actually?
Sir,
Yes, sir.
Habib.
Getting
Sir,
into
some
class.
Habib.
Ah,
Sir, one boy with name Habib.
you know, down. I'll take care of this. Trust is like a paper. That fellow only. Hmm?
No, sir. That is Hasib.
I am Hasib, sir. That is Habib.
Sir, that boy left the class.
Abrar is there, no? Not there?
Yes, sir, I'm there.
Hmm. Take care when today madam is on leave. Sunday, no? I made it the host, okay? Any
Yes, sir.
disturbance, mercilessly remove, no question. 1 second, 2 seconds, nothing. Be ready. That's all.
Yes, sir.
Shall I turn this?
Yes, sir. Completed.
Yes, sir.
No, forget about scientific tempo. Common sense are also not, children are not having nowadays. Pathetic situation. Parents, how they are rearing up the children. Minimum sense they don't have. Shall I turn this?
Yes, sir.
Then note down this. Is it visible, man?
Visible,
Clear,
sir.
I
Visible,
think,
sir.
huh?
Yes, sir.
Completed?
1 minute, sir.
1 minute, sir. 1 minute.
Shall I turn this?
1 minute, sir. 1 minute.
Finish this?
Last line, sir. 1 minute.
Just a minute.
Immediate, sir.
Twice completed.
Yes, sir. Done, sir. Yes, sir.
Done, sir.
If you want to take a screenshot,
Completed, sir.
right? So usually we use this relation only to calculate. So now in this he has given everything. Now what is D? Is the question?
1 centimeter.
1
1
centimeter,
centimeter.
na? Alpha 2 is given. 19 minus 11, 10 power minus 6. This is 10 power minus 2. What is delta theta, man? Change in temperature 100, no?
100
Now
degrees Celsius.
this you convert into meters. SI. This is 8. 10 power minus 4. If it goes up, is it correct? 8 ones are 8.
12 point something, sir.
25.
Agreed?
Yes,
Yes,
sir.
sir.
Yes, sir.
Approximately you'll get this. Fine?
Yes, sir. 12.5. Yes, sir. 12.5.
If you know these types, they're asking in the exam and mains, NEET. Right.
1 minute,
Finish?
sir. 1 minute.
1 minute, sir.
Finish?
Yes,
Yes,
sir.
sir.
Complete.
Sir, finished, sir.
Wait, sir. So this is
Not.
sir. Over, sir.
See here. See here. This is an object. Now you are using some scale. This is some scale you are using. Okay, so this is 0 of the scale. So this is 2. 4. And you will say that what is the object length, you will read 4 centimeter. This is at theta 1. That means here temperature at which markings on the scale are made. These are the markings on the scale. Okay. At higher temperature, what will happen? The distance between any two markings will change, Now the same object, if I measure, due to thermal expansion, what will happen? The
The length
scale
will
will enlarge.
Yes, sir.
Yes,
4 centimeter will be more.
this may be, suppose this is 0, this will be,
from 3 centimeter.
so you may have here as 1.1 centimeters. Example I am showing. That
Okay,
Yes,
sir.
sir.
means you
4
can
centimeter.
see that the object scale will read
Less length.
as measured by scale. Understood this?
Understood, sir.
Similarly, when the temperature changes also this will occur. That means the temperature decreases, what will happen?
It will show more length, sir.
It will
Hmm.
be less.
Scale decreases.
This much common sense is enough for NEET, man. Nothing else. So in this case, what happens is you will see that this is 0, no? Very near it will come.
Yes, sir.
6 centimeters. Okay, here at lower temperature,
Length, sir.
hmm, till here any doubt is there?
No, sir.
Shall I turn this?
1
No,
minute,
sir.
sir.
1 minute.
Sir, wait a
Sir,
minute.
what is this? scale and object are made of same material?
Pardon? Hello?
If both scale and object, measuring
Pardon?
scale and object,
One is scale, the other is object. This is the object, man. This is the scale.
No, sir.
What
He's
is all?
asking what if the object and the scale are both made of the same material?
And that's what I'll tell that next. Next is that. Okay. That means here what is the correct length you want? Will be the true value here you will have L plus L
Yes.
alpha higher temperature minus lower temperature. Agreed? Here the correct length will be at lower temperature. Original one minus,
Alpha.
because this expansion you should remove, no? It is
Yes, sir.
expanded more. Followed this?
Yes, sir.
Shall I turn this?
Sir.
Yes, sir.
1 minute, sir. 1 minute.
Sir, 1 minute.
Sir, just a minute.
Shall I turn this?
Yes, sir.
Yes, sir.
Yes, sir.
Completed.
Some boy said 1 minute. So when markings on scale are made at temperature say T1 degrees, that is we call calibration. Agreed? When temperature increases, what will happen?
Length decreases. length decreases at length.
Length of object.
Is less than the actual length. So plus
The expansion,
alpha
no?
sister changes
That is what we learned just now, no?
sister.
Is it clear?
Yes, sir.
When temperature decreases, then what happens?
Length of an object as measured by upper scale is more than the correct length. L, L minus L alpha delta T. Length of compression.
Do you agree with this or not?
Sir, calibration temperature is room temperature, right? Typically.
Yes. Is it clear?
Clear, sir.
So 1 plus alpha or 1 minus alpha?
I have taken, reversed this.
Okay, sir.
Or you want to keep in the same thing, you keep nothing, it's no wrong. Anyway, you can do. Finished this?
Yes, sir.
1 minute, sir. 1 minute.
1 minute.
Done, sir.
Now let us see the case when both object and scale are expanded. Okay, let calibrated at temperature theta 1. Means that theta 1 you have made in the markets. That means at theta degrees, 1 centimeter on scale is exactly 1 centimeter, no?
Yes, sir.
Okay. Okay. Will be how much, man? 1 plus
Yes,
alpha of scale into higher minus lower. Do you agree with this?
agreed, sir.
Clear?
Yes, sir.
That means L centimeters of scale is L into, do you agree with this?
Yes, sir.
Understood or not? This is what you got now.
Yes, sir.
Okay. You always remember this one also. Final minus initial you should take. Delta means that only now.
Yes, sir.
So here also 1 plus alpha final minus initial. Clear?
Yes, sir. Initially at high temperature,
So instead of this high and low, you just use this, that will be easier. Okay?
yes, sir.
Same thing we wrote no previously.
One minute, sir. 1 minute.
Sir, 1 minute, sir.
Finished?
Yes, sir. Okay.
So always Understood this? Clear?
Clear, sir.
Right. Now let us go to the other aspect. Suppose we have a scale. A scale is calibrated at theta 1 degree Celsius. Okay. And length of rod as measured by scale. See, R means LR. Okay, Lord, this is agreed so far. Now, at higher temperature, what will happen? Scale will expand, no?
Yes, sir.
Agreed.
Scale will expand.
How much?
1 plus alpha. Final delta H.
Do you agree with this?
Yes, sir.
Now, rod will be
Actual length only.
hmm,
Sir, both are same, sir.
no, both are different materials, no?
Okay.
Now, see, how do you make measurement? You will say that, see, this pen is 10 centimeters, means there are 10, 1 centimeter markings, no? So, here, length of rod as measured by scale is by how many centimeters of scale are there? You agree with this or not? Hello?
Yes, sir. I agree.
All of you follow this or not? An
Completely, sir.
object is having
Yes,
say
sir, I
10
agree.
centimeters. That means 1 centimeter marking of the scales are 10 in that. Similarly, the length of the rod is there. How many new centimeters are there in that? You have to find now.
Yes, sir.
Yes, sir.
Yes,
Understood
sir.
this clearly?
Understood, sir.
Yeah. Yeah. Can I write like this? That CV's fill is absent now.
Yes, sir.
Who, sir?
He's there, sir.
He's there, sir.
He's not opening his mouth.
I'm present, sir.
What is this shocking?
No, sir, I understood. That's why I did not ask anything.
Till here you followed?
Yes, sir.
Now this is very small, no?
Yes, sir.
Compared to this is very small, no?
Yes, sir.
This is the length of the rod as measured by the scale. You understood this binomial theorem? 1 plus x whole
Yes, sir.
power
Yes.
minus 1 is. Understood this?
Yes, sir.
Sir.
Yes, sir. X is very small.
Hello?
Yes,
Yes,
sir.
sir.
Yes, sir. One
Yes,
minute,
yes.
sir. Writing.
Following or not?
Sir, can you
Yes.
explain
Following,
that
sir.
part, sir? Length of rod as measured by scale.
See, one apple is 5 rupees. In 20 rupees, how many apples will get?
4.
4.
How
4.
did
4.
you get? No, no, the person who asked out, let him answer. How many you'll get, man?
4, sir.
How did you get that?
Adding, sir.
Adding. You're adding. In 20 rupees, how many 5 rupees are there? You're dividing, na? Because each 5 rupees corresponds to one apple, na?
Yes, sir.
In
Yes.
20 rupees, how many 5 rupees are there? 20 by 5.
4.
4.
5.
Okay.
Yes, sir.
So each 5 rupees is one apple. Fetching you one apple. Do you agree with this or not?
Yes, sir.
Similarly, here, this is rod length actually. But that is measured by what? On scale. In that scale, the marking between two markings is not 1 centimeter. This is actually how much it has become? 1 plus alpha s into theta minus theta 1. Now, how many such mark? That is only measurement, no? An object is, suppose I keep a pen here, I say it is 3 centimeters. Why? Because there are 3, no? Hello?
Yes, sir.
Yes, sir.
So, in this, how many these new centimeters are there? I have to find. That is only reading, no?
Yes,
That's
sir.
why I am dividing. Understood this or not?
Yes, sir. Thank you.
See, why I am asking so many times understood. This should be conceptually remembered by next. If you mug up formulas and all, you will forget by next year, man. So that's the reason why I know the reasoning. Simply mugging up the formulas will not give you anything. Do you think you'll remember all this biology and chemistry till next year? Huh? After second year, you'll forget about first year. You'll do first year, you'll forget about second year. That's why I'm asking understood so many times. Completed this?
Yes,
Hello.
sir.
1 minute, sir. One
Yes,
minute. One
sir.
minute.
Shall I turn this?
1 minute.
Yes,
One
sir.
minute, sir. 1 minute.
Sir, one
Sir, can you show the upper part, sir, for 1 minute? I will take screenshots. Thank you, sir. Done, sir.
Is it clear?
Yes, sir.
Sir.
Yes, sir. Clear.
Shall I turn this?
Sir.
Yes, sir.
1 minute, sir. 1 minute.
Finished this?
Yes, sir. Finished.
So, what we learned this is what we got now.
Okay.
Is it clear?
Yes, sir.
Right. Note on this.
Completed, sir.
Completed?
1 minute, sir. 1 minute.
What you wrote earlier, previously, just sit and read it on that.
Yes, sir. Yes, sir. Completed.
Completed?
Yes, sir. Completed.
Just a second.
Shall I turn this?
1 minute, sir. Writing.
Finished?
1 minute, sir. 1 minute. Last line. Sir, that is 1.26, right? Le- 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 Linear expansion of steel.
Here. 1 point in 10 power minus 5. Visible now?
Yes, sir. Visible now. Completed, sir.
Right.
1 minute.
This one?
Yes, sir.
Completed.
Completed, sir.
Yes, sir. Completed.
See here, what is the length of steel tape, steel rod, man?
Not given, sir. It is given as 63 centimeter at 45 degrees Celsius.
Obviously, it is given.
1 meter long, sir. Steel rod or steel tape, sir?
Steel
Steel,
tape, no, sir.
Measured value,
steel rod is 63 centimeters, sir.
So
alpha of
steel rod is
steel.
63. Steel tape is 1 meter long, sir.
Yes, sir.
Hello?
Yes, sir.
Yes, sir. Steel tape is 1 meter long, sir.
Steel rod is correct one is 63. It is 63, sir.
A steel tape 1 meter long is correctly calibrated. Okay, then what is the temperature actually? The length of a steel rod measured by this tape is found to be okay. So he gave that higher temperature one, no?
Yes, sir.
He is asking, he gave the higher temperature, higher values. Understood this?
Yes, sir.
Understood, sir.
Sir, he gave the values only for the tape, not for the rod.
Yes. What is the calibration temperature?
27 degrees Celsius.
27 degrees Celsius.
He is asking what is the steel length on that day?
Sir, length of a rod at higher temperature is 63.
Pardon? So at higher temperature, what will be its length?
63 centimeters.
What is the steel one he gave?
63, sir.
45 degrees
1.2
Celsius,
into
no,
10
sir.
power.
Sir, theta 2 is 45 degrees
45
Celsius.
degrees Celsius, sir.
Do you agree with this?
Yes, sir.
Agreed?
Yes, sir.
Now, how much? Same value, no? Alpha. It is correct at 27 degrees now.
Yes, sir.
Yes, sir.
Now, what is given? Means what we should do? L naught by how many such centimeters are there, no?
Yes, sir.
This is given as 63, I think, no? Am I
0.6.
right?
63 centimeters.
Understood this? Is it clear?
Clear, sir.
You are supposed to find L naught. L naught is nothing but 63 into 1 plus by
Sir,
correct, no?
in the first equation, the measured length is 63 na sir. We have to find its true length. So true length will be L naught is equal to 63 into 1 plus that will come na sir in the first equation.
True length of the rod is L naught, okay. Temperature is increased.
Yes sir. So measured value is 63 na sir. So we should multiply by 63 na sir there. Its length is 63 into 1 plus 1.2 na sir.
No, no, 63 is as measured by the scale is saying.
Yes sir.
Understood this?
Yes, yes, understood. Got it, sir.
No, sir.
What now, sir?
I didn't understood, sir.
One minute, sir. 1 minute. Last
No,
line.
again, I'll explain. One boy he says he will not understand. No? See, what is the length of tape, man?
1 minute.
100 centimeters
Yes,
he
sir.
gave. Do you agree
Yes,
with
sir.
this? I'm explaining
Yes,
once
sir.
again.
Yes, sir.
Okay. So length of this tape at what temperature are you using?
27 degrees.
Hopeless fellow.
45
45
degrees.
degrees. Alpha
Yes, sir.
into 45 minus 27. This is 100 centimeters. Alpha of steel is given. Understood till here?
Yes, sir.
45 minus 27. Okay, this is at 45. Do you agree with this? Therefore, I can say that if you simplify this, you will get this. Till here you followed.
Yes, sir.
Now this is see this length is divided into how many parts? 100 parts, no? 100 centimeters, no? We should need.
Yes, sir. Yes.
Yes,
Clear?
clear, sir.
Length of 63 centimeters. This is 1 centimeter, this one, you know. It is measuring 63, no? Do you agree with this?
Yes.
This is the actual length of the rod. Clear?
Yes, sir. Yes, sir. Clear.
At what temperature? Understood this or not? Clear?
Yes, sir.
Because at 63 it is correctly showing. At higher temperature it should supposed to show like this.
Yes, sir.
Understood this?
Yes.
Now is it clear? Malakpet.
Yes, sir. Thank you, sir.
Shall I turn this?
1 minute, sir.
1 minute, sir.
No, sir.
So can you once show the previous page?
Completed?
Yes, sir.
Will you complete this or not?
Done, sir.
Shall I turn this? Hello?
Done, sir. Yes, sir. Completed.
Which previous one, ma'am? This one, huh?
Yes, sir.
This is wrong, that's why. Somewhere explanation is not good. This is only better.
Okay.
Understood this?
Yes.
So can you get a break?
Pardon? You want break, huh?
Short break.
How much time you need?
No, sir.
11:37. You'll come by 11:50.
Yes, sir.
It will
Yes,
come
sir.
by 11:50.
Okay,
Then
sir.
Okay,
we'll
sir.
close by 1 o'clock, right?
Okay.
I'll start the class. Even one student is there. I won't wait.
Okay,
Okay, sir.
sir.
Yes, sir.
Sir.
Right,
Yes,
fine.
sir.
Sir, the previous method was also correct, right?
Correct only, but that calculation become hectic, man.
Yes, sir.
No, sir. We can cancel out the one and the above numerator and the denominator because of the negligible. That's
But
1.2 into 10 raised to power minus 5.
you will get 63.
Yes, sir. Approximately 63.
Okay, right. If you feel comfortable, do it. Because one fellow said he did not understand. That's why I took for another method.
Yes, sir. Yes, sir. Thank you, sir.
Right.
Hello, sir.
We are back.
Hello, sir.
Sir, start the class.
Hello?
Yes, sir.
See, you have something called as moment of inertia. What is that? You don't know. Okay. However, we'll come across in rigid body dynamics. Moment of inertia is simply the product of mass of the body See, suppose this is mass m, this is r. Like that, another particle is there, m2. This is r. So this is another particle m3, r3. This is the axis. When this rod moves, all this will be rotating, no? In
Yes, sir.
different circles, no? So whenever a body rotates, different particles will be, when a body rotates, okay? Till here you followed? So we call this as moment of inertia. So we multiply this mass of the particle into r square. Sum of this is called, more about that we shall learn shortly in rigid body dynamics. Okay, now why we need is when r changes, what will happen? This is I equals, okay. Now if you take delta log of this, remember this, hello?
Yes, sir. Yes, sir.
Can you take like this? We'll do one thing. What is delta E here? M1 won't change, Only this
Yes,
will
sir.
change,
Sir will change.
Sir, is
This is
it the sum
what?
of mass and radius together or just mass?
Mass into radius square. Here I am showing,
Square, yes, sir. So that's the whole sum of the mass
Hmm.
into radius.
Mass of each particle into its radius. See, M1 R1 square, M2 R2 square.
Understood, sir. Understood.
So
Sir,
this
clear.
is the moment of inertia. Agreed?
Great, sir.
See, suppose this is x square now. Then what is change in x?
DX.
So delta y equals 2x dx now. Now suppose I am taking r square. Delta y is delta 2r delta r. No? Do you agree with that? Same thing I wrote here for 2r delta. Do you agree with this?
Agreed, sir.
So this is change in x square now. What is this? Change in
Y.
x square now. Change in y is what?
X square.
change in y. That is change in x square only, So similarly, clear on it? Change in r square, sorry. Till here, any doubt is there? Shall I turn this?
1 minute, sir.
Shall I turn this?
1 minute, sir. 1 minute.
1 minute.
Completed this. Hello.
Yes, sir.
Yes,
So
sir.
what is that you got here, man? And what
Yes,
is
sir.
delta I you got? Any doubt is there in this?
So that delta
Sir, change in y, change in r square.
Y is r square only, no? Hopeless fellow. What is y? Oh,
Yes, sir. Yes,
what
sir.
doctors, man. No, you have negligence, man. Many children. What is that? Just look over what is given. Till here you followed.
Followed, sir.
So what is r actually? Length only, no? R is some length. What is this equal to?
R
Original
square,
radius.
35.
What is that equal to? So
I
change in moment of inertia is
2 delta R पे R ना sir. 2 is subscribe.
pardon?
That 2 delta R पे R will come ना sir.
Okay.
Yes.
Is it clear?
Clear, sir.
Clear.
Shall I turn this?
Yes, sir.
Yes,
Completed.
sir.
Anyhow, don't think much about that moment of inertia. You have something called as rigid body dynamics, and that will be coming across many aspects of that. Okay. Now let us see. Whenever they're all interconnected. See, always remember that this is I omega is constant. All this you may not know, but for the time being, I just continue to say, I mean, don't bother much about it. We'll come back this in chapter Moment of Inertia. So here, if I take L and I, what is that you have here? Delta I by, remember,
Yes, sir.
this is 0, no? Clear?
Yes, sir.
Okay, you just note down this and you can, we'll come back that in other chapters. The next aspect of this is, see, you have seen that your photo is there. When you give it to enlargement, what will happen? Everything will be expanding, no?
Yes, sir.
You won't have this contraction, this expansion like that, no? So what
Everything
we
is
can
Yes, sir.
say, thermal expansion is similar to what? Photographic enlargement. See here, this distance is increasing or not? I distance. Okay, even this length is between distance, any 2 point distance is increasing or not?
Yes, sir. Yes, sir.
Increasing.
there.
Okay, so distance between see, for example, you are having some circular ring. Okay, this is the circular ring. Understood what I am speaking?
Yes.
Now, this circular ring has, so this gap is x. The okay, this thickness is d. This is r. You're able to understand this? This gap.
Is X. Thickness is D. D is the.
Now, upon heating, what will happen?
X will expand, D will expand, and R will expand, sir.
Yes, sir.
Remember that x dash will become alpha of the metal only. R dash will become,
R1 plus alpha.
this will also become D dash, means
N plus D.
everything will increase. Understood this? Now, generally, what you'll think, no, this will increase, so this will decrease, nothing like that. Okay, so obviously, what will happen? Since R increases, even circumference increases, no?
Yes, sir.
Any doubt in this?
Yes, sir.
Yes, sir.
Is it clear?
Yes, sir.
Is it clear or not? Shall I turn this?
Clear, sir. 1 minute, sir.
Oh, thank you. అయితే రే Shall I turn this?
Sir,
1 minute, sir. 1 minute.
Shall I turn this?
1 minute, sir. 1 minute. Writing.
నా ప్రింట్ చేస్తాయి ఇప్పుడు వాట్సాప్ ఫార్వర్డ్ చేస్తాను.
Clear?
Clear, sir. Completed.
Right. So whenever there's a hole in a plate, there's a hole in a plate, no? When this is heated, what will happen?
Hole will
Diameter of the
expand.
hole, diameter of the hole,
Increases.
now if there are two small holes like this,
Both of them will increase before they meet with each other.
they'll meet with each other. That is the reason why I give so many examples. This distance will also increase, no, hopeless fellows.
Yes, sir. Oh, sorry, sir. Yes, sir. The distance will also increase. Never mind. Sorry, sir.
100 times, and this is the mistake. That's why people will feel exam difficult, no? Exam is easy only. Suddenly at that moment, you'll do some error. Here, what are all increasing?
A, B, and the radius and the distance between the two holes.
It only distance between any 2 points must increase.
Yes, sir.
Clear?
Clear, sir.
Shall I turn this?
1 minute, sir.
Sir, just a minute, sir.
Shall I turn this?
1 minute, sir.
1 minute, sir.
Sir, in this case, at certain stage, it will fracture,
Just a
right?
minute, sir.
Pardon?
At some stage, or at some point of heating, this will fracture, right?
All that will happen.
Done, sir.
Finished this?
Yes, sir, completed.
Yes, sir.
Done, sir.
Followed this?
Yes, sir, followed.
Now we have the expansion of solids. Sorry. Liquids. No? A complete expansion of solids. Okay. See, you cannot supply you want to heat water, that water will put it on the gas stove directly.
No, sir, we have to put it in a container and then keep it on the stove. We use a conductor.
Do you agree with this?
Yes, sir, agreed.
That means here when a liquid is heated, what will happen?
Temperature increases.
Both the container
And liquid.
And the liquid's temperature increases.
followed this. We can say that suppose we take a vessel of volume V. Okay. Understood this? Okay. Then you can see what is the expansion of the liquid.
Sir, volumic expansion.
The
Gamma.
new original one, gamma of liquid.
Yes, sir. Yes, sir.
What you have? Till here you followed.
Followed,
That
sir.
means now you can see definitely liquids will expand more, no?
Yes, sir.
Okay, shall I turn this page?
1 minute, sir. 1 minute.
Sir,
Hmm.
can you show the previous page once, sir? I will just take a screenshot. I got disconnected.
What is the previous page?
1 minute, sir. 1 minute. 1 minute.
Shall I turn this?
1 second, sir. Please wait.
Sir.
Just a minute.
Done, sir.
Finished?
Yes, sir. Completed.
Bro, take this. This one only, I think.
Yes, sir. Thank you, sir.
Finished?
Yes, sir.
See here, understand one thing. Suppose this is a volume and you are filling till here. This is a liquid now. When the vessel expands, you can see that there is an expansion in the vessel also. The vessel expands like this. The red colored one is extra length of the vessel. Understood this?
Yes, sir.
Length and breadth are expanding. Now, even the liquid which is supposed to be here will rise. Now, can you tell this expansion is due to what? It is not absolute expansion. The what you see is, what is this? Expansion of liquid with respect to the vessel. Okay. What is this?
Expansion of liquid with respect to the vessel.
Change in volume of liquid relative to container. Do you agree with this?
Agreed, sir.
That is nothing but relative means yes or
With
no, no?
respect to. Yes, sir. Yes, sir.
Previously you got substitute this. Okay, I'll do like this. Understood this? Clear?
Clear, sir.
See, this is gamma of liquid with respect to the vessel, no? So this is what you call it as gamma apparent. So remember that this is understood this. So liquid has two volume expansions. What are those? Real expansion and apparent expansion. Followed this?
Sir, one doubt, sir. Sir, how is VL equal to VS? We are substituting over there, right?
Hopeless fellow, we have taken that equal now initially. Fully
Sir,
filled
one
now.
show that slide,
Fully
sir.
filled, but that is partially filled, no, sir?
Which one?
The next one which
Yes,
we took the
man, you can
example.
find. No, otherwise you'll take those values. For simplicity's sake, I have taken this.
Okay, okay, sir. I got it.
Because those values are not known, no?
Yes, sir. Yes, sir.
I like it, I'm telling you, you have to do lot of work to come up in life. Somewhere it went wrong in school. That is the reason why I'm telling. I'm trying my level best. I can give four formulas and finish the syllabus. But that will have adverse effect finally. That is the reason why people write first long term, second long term, third long term. Anybody has said MS school? Hello?
Yes, sir. I am from
Yes,
MS.
sir.
You know we have IC batches, no? Kausar takes.
Yes, sir.
Yes,
Yes,
sir.
sir.
Go ahead and inquire. Third long term, fourth long term, they'll be studying. Reason is first time only the basics have gone. So any long term, the same thing, only long term only. Put hard work, man. And you won't give time
Sir,
also
you
the
have
problem.
to long time.
You cannot sit for some time, man. That is the problem. Biggest drawback you children have is I am able to sit at this age for your sake. Today is a holiday for me also, no? Who is observing my teaching when management is there? According to them, they feel that I am taking rest now.
No.
Then I should have, because if people are very slow learners, I have to take all this. If you are fast by this time, I should have completed the syllabus. Every aspect minutely I should teach. Actually, I should get irritated. The funny thing is, you get irritated to attend the class. Anytime we give break, now some people will escape as if they are coming to say, do something good for me by attending the class. Their presence itself is like presence of Almighty. They're feeling. We can't change them. Now you be lazy, lifelong you will be suffering. What we can do? Shall I turn this?
No, sir, no, sir.
Anybody can be successful, man. If you do hard work, there is nothing like intelligence in the world. Okay? Slow learners, fast learners. So slow learners should spend more time. Slow learners, you don't spend time, both are negative only. No? Shall I turn this?
Yes, sir.
Yes, sir. Completed.
So remember that unlike solid, liquid has two expansions. What are those? One is,
Real
we
expansion and
sometimes
apparent
write like
expansion.
this also. This is coefficient of and you have gamma apparent. Or they'll write it as gamma A. Okay. So now whenever we have volume of liquid, container volume, do you agree with this or not? Clear? Now, if then what will happen? I am filling the liquid completely. Till here you followed.
Followed, sir.
Gamma L is greater than gamma S. Then what will happen? Liquid will expand more, no?
Yes, sir.
This implies that
Sir, your video got stuck.
no, it
No,
is
sir.
fine, no?
No, sir.
Huh?
No, sir, fine only.
Level of liquid
My network problem, sir. Sorry.
solid means container. Then what will happen? So what happens? Till here any doubt is there?
No, sir. Clear.
Is it clear or not?
Clear, sir.
Clear, sir.
Right.
1 minute, sir. Writing.
You want to mug up, it is not possible, man. This subject is that what we can do. Shall I turn this?
No, sir.
Boys, complete it.
Yes, sir. Completed.
See, what is that gamma apparent you have? So gamma liquid is gamma apparent plus gamma solid. Okay. Now you can see that, okay, if you observe this, you'll be knowing this is true. Because water has some gamma, alcohol has some gamma, like that. Okay. Whereas gamma apparent, do you agree with the nut? S means solid.
Agreed, sir.
See, for example, they asked one question like this earlier. The coefficient of a liquid in copper vessel is C, and in silver vessel is S. Coefficient of volume expansion of copper is gamma C. Understood this? Understood the question?
Yes, sir.
Understood, sir.
Next, frame the equations. This is what? Gamma, no?
Sir.
In
Yeah.
silver. This is liquid expansion is say copper vessel, no? Then you are taking a silver vessel. Liquid expansion won't change. This
Minus
is gamma of silver. Agreed? Now from these two, if you subtract one from the other, what you will get? Now we have gamma S is, this is 3 alpha S now for silver. What is alpha S? That is what he is asking now. Understood this or not? Hello?
Understood, sir.
Plus 3 alpha.
Gamma is 3 alpha. Remember this?
Yes, sir.
Yes, sir. 1:2:3 ratio, sir.
Any doubt is there?
No, sir.
No, sir.
Shall I turn this?
Yes, sir.
1 minute, sir.
Completed.
Finished.
Sir, explain the last part, sir, please.
This one.
Yes, sir, that one.
He gave this, no? Copper. Gamma apparent is when you're taken in a vessel. He has taken copper vessel. It is C. Liquid expansion is same, no? This is gamma C. Copper. If you take silver, this is gamma S, no? This won't change.
Yes, sir.
I have subtracted that. From there I need gamma S. From there I'll get alpha S.
Sir, how it be?
Huh? Hello? Earlier we have done that. Remember?
Yes, sir.
Yes, sir. Yes.
That means you're not opening the book also. Clear?
Clear, sir.
Yes, sir, clear.
Shall I turn the page?
No, sir.
So, sir, the material of the vessel did not affect the volume of expansion of liquid, sir.
The real value will never be changed, no? Apparent value will change. Real value, water is there. Its density is same, no? Whether you take it in a small glass or in a big water bottle, the density won't change, no?
Yes, sir.
Mass will change, volume will change, but mass by volume remains constant. So here, this is does not, that depends only upon the material. Shall I turn this?
No, sir.
Completed?
Yes, sir.
Yes, sir. Completed.
So what we can learn from here is coefficient. Absolute or real only means that it won't depend upon other factors except nature. Agreed? Okay. Understood this? It
Yes,
is
sir.
also
Understood.
equal to 2 beta s solid. Sorry. Oh, beta is 2 alpha s. No? Understood this?
Yes, sir. Understood.
Understood.
You have knowledge of upthrust during schooling.
Yes, sir. Buoyancy.
Shall I turn this?
1 minute, sir. No, sir.
Done, sir.
Just a second, sir.
Finished?
Yes.
See, suppose it's a vessel and you are filling it till here. Now, what is volume of air is what is VL?
Volume of liquid.
It's the volume of vessel.
Okay. Now, if we take delta V, now for volume of vessel unoccupied by liquid, that is what should be constant? Do you agree with this or not? Hello?
Great, sir.
So here you have this volume of the vessel, gamma of the vessel, delta theta, volume of liquid, gamma of the liquid. So when volume of the vessel, gamma of the vessel is equal to this, understood or not?
Sir, the volume of the liquid is also constant, right?
It will expand now, man. Brainless fellow. This will expand now. Why
Sorry,
it will
sir. Sorry,
change?
sir. Understood, sir. Understood, sir. Sorry, 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 sorry.
Understood this?
Understood, sir. Understood.
Sir, as liquid is expanding, the volume of air will change, no, sir?
Yes, man. It won't change if this condition is there. Read all this for volume of vessel unoccupied to remain constant only.
Okay, sir.
Understood this?
Understood, sir.
Understood, sir.
It will change because the liquid will expand and vessel will also expand. Suppose it should not change. What is the condition? I want the condition for liquid not to, the air should not have more volume than it used to have. That means even the vessel expands, liquid expands, the volume of air should not be changing. What is the condition? Their wishman examiner will ask any question you are supposed to answer, you'll get a seat, that's all. So that fellow may ask this also. Note on this.
Sir, 1 minute, sir. 1 minute.
Still not completed.
Done, sir.
Here.
So should we leave for namaz after this problem?
Yeah. Now also you can leave, man. No problem. Finished this? Usually
1
Gausser
minute, sir.
class will
1
be
minute.
till what time and daily? Zoology class what time?
1:30, sir.
Then why 1 o'clock only suddenly you got that prayer? Regularly, tomorrow you tell the Gausser also the same thing. 1 o'clock we will go to prayer. Then you get the answer, perfect answer he will give.
What is this, sir?
Hmm?
What he will
Alright?
say?
Tomorrow you ask man, class is till 1:30 now. You tell him like the same thing at 1 o'clock. 5 to 1 you tell sir at 1 o'clock we will go to Namaz. You will know what he will say. 1 hour. Because he is knowledgeable than me now in this aspect. Those will complete this problem. Those who won't listen. Shall I turn this?
1 minute, sir. 1 minute, please.
I decided to go ahead with the syllabus. Those interested regularly join the classes. Already I told Afsar sir, it's very difficult. These people are not showing that much interest required for NEET exam or a IIT advanced exam. The amount of work you are keeping is not sufficient. Shall I turn this?
Yes, sir. Completed.
Yes, sir.
Straight problem, no? What is the
Yes, sir. Yes,
condition?
sir. Last line.
Same problem, see. How much mercury must be placed? What is the condition? Volume of the remaining space. Remaining space means what is that? Here only,
Whatever is there,
no?
sir. Yes, sir. Yes, sir.
So that should be constant. That means gamma of vessel into volume of vessel equals gamma of liquid into volume of liquid.
Yes,
He
sir.
is asking that volume of liquid only. Shall I turn this?
Yes, sir.
Straight. Use this equation, no?
1 minute, sir.
So he gave this volume, no? He gave
Yes, sir. 300 centimeter cube.
16.66.
this is volume is how much? 300 cc. Yeah?
Yes, sir.
Gamma of vessel is given, no?
1 into 10 power minus 5.
Linear he gave. He gave linear, not gamma. Gamma of liquid is given. EL is how much is asking. You will get exactly 50 cc.
Yes, sir.
Somebody
Right.
asked this. Anybody want the problem? You copy it. Till here, any doubts are there?
No, sir.
Sir.
Right. Complete this. Okay. Go ahead. We will meet tomorrow. Right.
Sir,
Right.
evening you can take a class, right?
Okay, sir.
But they won't. They won't determine. I know. No.
Sir, we are
No,
having
sir, we'll attend,
exams.
sir.
They are
Yes,
having
We
sir.
are
We
having
have
exams.
exams, sir.
exam tomorrow, sir.
JL40,
Sir,
sir.
Tomorrow exam we have.
evening,
Tomorrow
sir.
they have which exam?
Sir, JL40 is having today and we are having on Monday.
That's what both have exams. The problem is that. Anyhow, complete this. No problem.
Okay, sir.
Only upthrust portion is left over. After that, expansion of liquid is over. Next week, we'll complete that and start gases also. Don't worry. Not until here. Okay?
Yes, sir,
Okay,
completed.
sir.
Thank you,
Right,
sir.
right.
Bye.
All right, bye, bye, bye. యాదమ్మా ఒక్క నిమిషం మాత్రం జరుగుతాయి.
Thank you, sir.
Completed, sir. Bye, sir.
చూద్దాం అది తుడిచేమో వస్తాం.
Thank you, sir. Take care. Bye.